Hello again. We're going to continue our conversation about matter and how we classify it. So we just spoke about and thought about how to break matter up into different states, so solid, liquids, and gases. And now we're going to introduce a few new terms and provide another sort of schematic or way to classify matter and talk about it on sort of these large categories. So we'll look at this figure here on the slide. Matter can be kind of separated in first along the lines of whether or not it's a pure substance over here or a mixture. So very broad terms, but it's a good way to begin to think about what things are made of. If you just look at an object and wonder, what is it made of? We can first begin to think about whether it's a pure substance or it's a mixture of different substances. So that's a broad, very, very broad categorization. And then again, you can kind of break down pure substances into what we're going to call elements and compounds. So this is just kind of an overview, and now we'll go through and really introduce a few of these terms, and we're going to start here with elements. So let's go ahead and take a look at that. Okay, so an element, we can sort of define that first. The simplest type of substance with unique physical and chemical properties. An element consists of only one type of atom, and it cannot be broken down into simpler substances by physical or chemical means. So just read that definition so that we kind of hear it and see it in more than one way. But clearly, as a chemistry student, elements are something to know about and sort of understand how they are the building blocks of matter. And then we can kind of contrast that with a molecule. A molecule is a structure that consists of two or more atoms that are chemically bound together and thus behaves as an independent unit. So if we go back and just think about examples, we'll look at the periodic table in a minute, but carbon, for example, is an example of an element. Or hydrogen. How about hydrogen? Oxygen. These are some very common elements that I'm sure you've heard about. In terms of molecules, one thing to know about molecules is when we use the term molecule, we're only talking about combining two non-metals together. So that's something that I'll say over and over again throughout this quarter. But a molecule is something that combines two non-metals. So for example, water is a very common substance and it is considered a molecule. So we've got hydrogen and oxygen. So it sort of fits the definition here where we have two or more atoms that are chemically bound together. And so water is an example of a molecule. Carbon dioxide is another example of a molecule. So again, we'll come back to that and talk about that definition more broadly. So to follow up with our chemicals or our elements, here are some examples. So here's a chart of just a bunch of examples. We've got sodium, potassium, iron, copper, silver, gold, mercury. So you've probably heard of some of these, but getting to know the periodic table, being aware of which are elements and which aren't is a good place to start. The other thing to know about is the chemical symbol. So notice that sodium has kind of a, odd, well, actually all of these have an odd chemical symbol that doesn't, it's hard to see. If you wouldn't have thought that Na is the symbol for sodium. But just so you know, it comes from the Latin name. And so you can start to think about where these chemical symbols come from when they're odd like that. Potassium is another example, very common element, but it is symbolized with the letter K, again from the Latin name here. So these are all sort of odd: iron, copper, silver. They all have slightly odd chemical symbols that you'll ultimately need to get to know. But one of the key messages here is that we do symbolize each element with a symbol. Usually it's either two letters, it's one or two letters, and the first letter is always capitalized, uppercase, and the second letter would be lowercase. So that's just kind of a system that's used for symbolizing the these are kind of interesting major elements of the human body. So again, very common elements, but as most of you are thinking about the medical field, knowing which elements make up the human body or other biological systems is kind of interesting. And so as you go forward in your biology classes and your medical classes, you will encounter these elements primarily. So carbon is a big one, oxygen, obviously, hydrogen, nitrogen. Those are kind of the major elements. Oops, I got calcium in there, but those are sort of the major elements that make up the human body. So interesting to know that 99.3% of atoms, are made up of these 4 elements here at the top. So just kind of interesting information here. Okay, now we're full circle back to molecules again. And just to give you some examples of molecules, we just looked at elements and some examples of elements, and now we'll look at some molecules. And if you probably recognize this big structure here, I'm guessing you do. I'll give you a moment to think about it. If not, you will definitely be made aware of this. We're going to do some work with this molecule in class. It's the DNA molecule. So getting to know its structure is really useful for understanding a lot of biology and a lot about how the human body works. So very relevant to you and what you're trying to accomplish. So atoms combine to form complex substances, and these are called molecules, and they're sort of discrete particles that we'll talk about. Although DNA is a very large molecule, it is also considered discrete. So each composed of 2 or more atoms. We already kind of gave you that definition, but just to provide some examples, we've got oxygen has got 2 atoms of oxygen, and so it's considered a molecule of oxygen. It's O2. So oxygen in the air, for example, exists as O2, not just as one oxygen atom. And then I've already talked about carbon dioxide. We'll do more work with carbon dioxide. Things like ammonia, things like sugars, all of the molecules in our bodies are pretty much, or all of the substances in our bodies are pretty much molecules. Most of them quite large, like DNA. Proteins are considered large molecules. Carbohydrates are large molecules. So we'll ultimately get a glimpse and look at some of those molecules later, because those are very relevant to you. We'll also look at some small ones, and later you'll learn sort of about their shape and more about how these atoms bond together. So we'll think about bonding, but that'll come later. So right now you're just focused on kind of differentiating a molecule from an element, for example. All right. So then we need to introduce the term of a compound. And it sometimes is a little tricky to differentiate between a molecule and a compound, but I'm going to try to make that clear. Let's just look at the definition. A substance composed of 2 or more elements that are chemically combined. So that sounds very close to the definition of a molecule, but the key that makes it different is it's 2 or more elements. So in other words, we gave you the example that O2 was a molecule, right? I don't want you to think it's a compound here because it's not, but is a molecule. But it fit the definition because it had more than 2 atoms bound together. So that's why it fits under molecule, but it does not fit under compound because this needs to be 2 or more elements. So 2 different elements are chemically combined. Okay. Then let's look at the term mixture. I introduced that in the very beginning, and it's sort of a term you're probably familiar with, but in a chemistry context, it's you have to kind of think about what does that mean. So a mixture is a group of 2 or more elements and or compounds that are physically intermingled. Okay, not bound together, but intermingling. They're sort of mixing around together, kind of like a big soup, but they're not necessarily bound together. So we'll look at some examples of that in just a moment. But just so you kind of differentiate, compound falls under the pure substance, and then obviously the mixture falls under a mixture. Okay, let's look at compounds. So formed from 2 or more atoms of different elements. We saw that definition at first, but we just want to make sure we got that. And then now we'll look at some examples. They're always combined in the same fixed ratios. That's another thing to be aware of. So for example, this is the water molecule again. So it's H2O. Water is always H2O. So there's always 2 hydrogens and 1 oxygen. That's what it means by fixed ratios. Can be broken down into elements by some chemical changes. So for example, you could break water down. We actually looked at that in the last video. But you can, through a chemical reaction, break water apart into hydrogen and oxygen. So that can happen. It can be broken down into its elements. So that's sort of a broad scope of what a compound is. I want to say just a few words now. A couple of things. There are some, water is both a molecule and can be called a compound. So a compound is a more general term. Let me just get that down. Then molecule. Molecule is specific for this definition, so molecule has its own definition, but it's only with nonmetals. So keep that in mind. We will study the periodic table in more detail, where you really are able to find the metals versus the nonmetals, but keep in mind that molecules only have nonmetals, like hydrogen and oxygen, both nonmetals, so they can fall under the molecule definition. And like we did look at DNA. So DNA has carbon, oxygen, nitrogen, hydrogen, and phosphorus in its structure. And so those are all considered nonmetals. So that's why it's considered a molecule. Okay, we'll keep talking about that. How about mixtures? So mixtures we break into two types. One is a homogeneous mixture. The other is a heterogeneous mixture. So the homogeneous mixtures have the same properties throughout the sample. So something like an orange juice, although it's a big mixture, you've got lots of things in there, water and vitamins and citric acid and all sorts of things mixed in there. You've also got, but it looks uniform throughout. So the same properties throughout the sample. It looks kind of uniform or homogeneous. Then you can have a heterogeneous mixture in which you can actually visibly see two different layers. Salad dressing is a great example of that. So it's not uniform throughout, and you can clearly see that there is oil and water in there, or oil and vinegar. And then lastly, let's just look at our schematic here again. Just hopefully this makes a little more sense now, but if we start at this really upper level matter, take matter and we start to break it apart, can ask the question, is the piece of matter that we're talking about a mixture? Okay, yes, we go over here, and then we know that we have the two types of mixtures. But if no, then we probably have a pure substance. So we had things like water and sodium chloride that we just saw. If we had a sample of carbon, the element carbon, that would also be a pure substance. So then you ask yourself, can it be broken down into simpler substances? And if the answer is yes, right? So then we're going over here. So then the water and NaCl come over here, because yes, they can be broken down, so it must be compounds. Sorry. But the carbon cannot be broken down anymore, so it must be an element over here. All right, so that's just yet another way to organize and categorize matter. And I will end this video now, and we'll see you in a bit. Take care.